So it says some exponential equations can be solved using the equivalence property. Okay, so if you have this type of a situation where the bases are the same, so maybe you have like 2 to the x plus 7, and here you have 2 to the 2x minus 1. If the bases are the same, then in that case, the only way these could equal each other is if the exponents are the same. So you just set the exponents equal to each other. Now that only works when the bases are the same though. If I have like 3 to the x plus 7 equals 2 to the 2x minus 1, well, those bases don't match, so it doesn't make sense to set the exponents equal to each other, okay? So let's go ahead and take a look at that. Let me get my chat open. I have a chat here, okay. All right, so let's see here. Now this doesn't look like the equivalence, what do they call it, relation or equivalence property show is true on this one, but 125, I claim we can write as 5 to some power. So what do you guys think? What would be that power that would get us 125? Yeah, perfect. So 5 times 5 times 5, yeah, that's going to get us 25 times 5, and that is 125. If you had 5 quarters, you'd have $1.25. So it didn't look like it was going to apply, but it really does apply. Our bases match. Okay, so we're going to go ahead and use the equivalence property to say, okay, then the exponents need to match in order for these two to be equal. And then you just solve that equation, just like you guys have been doing all semester. Divide by 3, done. X equals 4/3. Okay, let's try another. Okay, so neither one of these looks like they have the same base. Okay, but I'm gonna write 1/4 as 1/2 squared to start with, because I'm noticing that 8 and 4, like let's see here, 2 to the 2nd is 4 and 2 to the 3rd is 8. So I'm kind of thinking, well, let me try to write them with base 2. They have base 2 in common, so that's my goal. All right, and the one on the right, well, we know 8 is 2 to the 3rd, right? So this is going to be 2 to the 3x. Okay, are we good so far, you guys? All right, now I just need to do one more little change to the left-hand side. The right-hand side's great, but I'm going to move this 2 squared up to the top, which means I have to write it as 2 to the what power? Very good. We know negative exponents is what puts them down in the bottom underneath the 1. So we're doing that backwards, huh? We usually don't do it this way. We usually go, oh, 2 to the negative 2nd, that means 1/2 to the positive 2nd. But instead of going this way with it, we're actually going to go that way with it. Okay. All right. And so now we have the bases are the same. So we're just going to set those exponents equal to each other. And divide by 3 to get the x by itself. X equals negative 2/3. Okay, so a couple little tricks on that one. Okay. All right. So I think that we already know where we're going because they used 8 and 4 again, huh? So I'm going to write the 8 as 2 to the 3rd, okay? And that 3 has to multiply by what's already in the exponent, you guys. Over here, I'm going to write the 4 as 2 squared, and that has to multiply by what was already in the exponent. I kind of skipped a step, so let me kind of talk about the step that I skipped. So if I have 8x to the 3rd, okay, so something x to the 3rd, well, we know that 8 is 2 cubed, okay? And we learned, I think it was last time actually, right, that when I have a power on a power, so an exponent on an exponent, that I multiply those two. that I multiply those two. And I think the example that I used last time, you guys, is what if I have x squared cubed, right? That's actually going to be x to the 6th. I multiply those two. And it's really clear if you write it out, right? X squared 3 times because it's cubed. So if I were to write it out 3 times because it's cubed, I can see 2 plus 2 plus 2 is what's going to get me that 6. Okay? So that's the reason why we want to be multiplying in the exponent on both of these, on the left side and the right side. Okay. Do you guys feel okay about why there's multiplication right here? Great. Okay, so the bases match. So we're going to go ahead and excellent. Okay. So let's see here. We'll distribute. And then we'll solve. So we have variables on both sides. Let's move the smaller of the two. So I'm going to move the -4. 7x plus 9 equals 10. Take away 9. Divide by 7, and we have it. X equals 1/7. So the hardest moment, you guys, was definitely this first step, because you guys are great at solving for x. So that was definitely a tough thing. So we wrote the 8 as a 2 cubed, and we just have to make sure that that 3 distributes to the exponent that already existed. Same thing for the 4. 4 is 2 squared. Just make sure it multiplies. Okay. All right. So that was the equivalence property. But we said, it's not like we can always write things as like bases. I mean, how nice was that first problem? I don't remember exactly what it was, but now this was a 125 sitting over here when that was a 5. I mean, the odds of that happening are pretty slim, you know. Usually I could just make it a 124 and it's like, okay, can't use that method, you know. So what do I use when I can't write them with the same base? Okay, so this is a great example. There's no way for me to express 7 as 2 to some power, unless that power would be a decimal, right? Okay. So what we're going to do is we're going to log both sides. Did they give you steps here? They didn't. Okay, so here's the steps. Isolate the exponential. Two, you're going to log both sides. And it could be any log. Most of the time we natural log. Okay. So natural log both sides of the equation. Okay. Then number 3 is use the power property. And then 4 is solve. Okay. All right. They have these. I'm surprised they don't have these written somewhere. Let me just check. Nope. Okay. All right. So there they are. So here we go. Well, we said we need to log both sides, right? So I'm going to natural log the 2 to the x. And I'm going to natural log the 7. Okay. Oh, step 1, isolate the exponential. Do you guys see that the exponential is already by itself? There's like not other stuff with it. If it were like 2 to the x plus 3 equals 7, then I'd have to like take this 3 away. So that way the exponential is isolated. Okay. If there were like a 3 in front of that guy, I'd have to divide the 3 out so that the exponential is isolated. Okay. So in this case, it was already isolated, so step 1's done. So step 2, natural log both sides. Now the reason why we're doing that is because we learned the power property says, hey, the exponents can go in front of the log. And that's great because it takes that x who was in the exponent, and we don't know how to solve when x is in the exponent. And he brings them down to level ground with everybody else. So now we can solve just like we usually do. So if I want to get rid of that natural log of 2, then I would just divide both sides by the natural log of 2. By the way, you guys, the natural log of 2, it's like, what is that? It's just something you could put in your calculator, right? You could hit ln2 and some number would come out. So this is just a number. In fact, I think it's 0.69, blah, 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 okay? So if you think of them as 0.69, like x times 0.69, and equaling some other number, let me see what natural log of 7 is on the calculator really quickly. It's like 1.95-ish. Wouldn't you just divide by the 0.69 to both sides to get rid of it? And then it would cancel out. So they don't look like they're numbers, you guys, but these logs, log of a number is always just some decimal. So think of it as a number as you're doing these things. Okay, Mecklenburg said natural log of 5 is some number. What would I do if there were a number there? All right, so these cancel out. Oh, I'm sorry, the right-hand side doesn't cancel out. And we get x equals the natural log of 7 over the natural log of 2. Now, if the directions say to like round or something, then I would go further, but this is exact, which is why we tend to leave it. The second that I go to my calculator and I hit natural log of 7 divided by natural log of 2, I now have something that I have to round. Like this is what my calculator, it ran out of, actually goes on forever. My calculator ran out of screen space, right? Yeah. Okay. So this is approximate, is why mathematicians don't like it as much. Okay. So just look at the directions and you'll know which one you're supposed to do. Okay, which one they want on Connect Math. Do you guys have any questions on that one? Spots that I can clear up where there might be some confusion? Okay, let's try another one. Okay, so step 1, isolate the exponential, right? Well, that's already done. The 3 to the x part is already by itself. So step 2, natural log both sides. Okay, so I'm going to do a natural log of this side and a natural log of that side. Okay. I just didn't feel like I could squeeze it in right here, you guys. It's a little tight. So I just wrote another line. That's what we're doing. We're just natural logging both sides. Okay. Step 3, use the power property, right? Use power property. So the power property is what says, hey, this exponent can drop in the front. So I'm going to drop that exponent in the front. Okay. Now I have to isolate the x. Step 4 is just to solve, right? Get x by itself, solve. Okay. So I'm going to go ahead and divide. Since all of these things are multiplying, right? All of them are multiplying. I can do it in one shot, you guys. I can just divide by negative 0.02 natural log of 3. And that'll make these two cancel, right? And then that'll make these two cancel. And that just leaves me with x. But whatever I do to one side, I got to do it to the other side too, right? To keep things equal. And there it is. It's kind of hideous. We're not used to our answers being this ugly, but that's what it is. And you can leave it like this. This is fine because this is exact. Or we can try to get, what that value is on our calculator. So let me see what that is. Natural log of 0.07 divided by parentheses negative 0.02 times natural log of 3 parentheses. I got about 121.028-ish. Yeah, yep. Usually we're getting a natural log in the bottom and the top. Yep. Yeah. Did anybody else get that on their calculator? I'm using a really weird calculator today. So I would just like to see, okay, great. All right, good. Okay. And we said that's not as good because it's approximate, but it's good if we really want to know about how big that number is, right? Okay. All righty. Step 1. I'm going to write them out every time. It helps us memorize. It actually doesn't matter, Ashlyn. So because we're multiplying, right? Multiplying, the order that you multiply in doesn't matter. 7 times 6, 6 times 7, they're both 42. So if you have like 3 times a natural log of 2, and you write that as like the natural log of 2 times a 3, okay? It really doesn't matter. So one of the things that I will say is when you're typing it into your calculator, if you don't use parentheses around the denominator, okay, so let's say you typed in natural log, and then you just hit the divides button on your calculator, and you hit this, guess what it's going to divide the natural log of 0.07 by? It's only going to divide it by this guy. It's going to do that math first, and then when it gets done, it's going to multiply by natural log of 3. Yeah. So how do we tell it that we really want it to divide by all of it? We have to wrap this stuff in parentheses, you guys, and then it'll understand, oh, okay, both of those go with it. Yeah. So try it. If you guys weren't getting the 121, try it now, give you a minute, and let's see if it comes out to 121 when you do it that way. Okay, good. All right. So I'm going to write these out. It helps us memorize it if we see it 20 times, right? That's how I learned. Isolate the exponential. It's kind of for me. That's why I write them out. Okay, so the exponential isn't isolated, huh? What do you guys think we would need to do to isolate it? Very good. I'm going to take this 4 away from both sides of the equation. Now we almost have the exponential isolated. I claim there's one more step to isolating the exponential. Yes, divide that 3 out. You guys are good at seeing ahead of time without being shown. That's awesome. Now we got the exponential by itself. So step 2, natural log both sides. So I'm going to take the natural log of this side. Ooh, and I'm lucky because I can move this stuff. I love that. Okay, and then on the natural log that side. And remember, the reason we do that is so that we can pull the exponent to the front using the power property. Okay. All right, so let's see what we got. Very good. I was just going to say it, but you guys beat me to it. Natural log of e, cancel each other out, right? So we can just cross that off. I'm liking this problem. So our last step would be to divide by 2. Now I want to show you 2 different ways to do this. Because you never know like what a multiple choice answer key will do or what connect math likes, okay? So one thing would be to divide by 2 and write it like this. Now it's kind of ugly because it's kind of like a fraction within a fraction. Okay, it's correct though, so that's fine, okay? But another thing that people do is they'll multiply by the reciprocal to both sides. And so they'll actually write it in the following way. You'll see both. Okay, so just in case, you know, you're taking a multiple choice test, I want you guys to be ready for both of those. So I'll put an or between these. Okay. All right. Oops, I forgot step 4, which was solve, which we clearly did solve. Okay. Yeah, yep, the half doesn't apply to the 7/3. So remember, this is some number in your calculator. And if you actually like plug into your calculator, so the question, I believe, this is a great question, because I told you my calculus students do this all the time. They'll actually distribute the half into that. Okay. So anytime a teacher's like, you know, or you're on a test and you're like, is that a thing? Can I do it? It looks good. It looks prettier that way. Just pull out your calculator and try it. So I'm going to put natural log of 7/3 into my calculator. Let me see what that gives me. Natural logs parentheses 7 divided by 3 parentheses. It gave me about 0.84-ish. Okay. Now I'm going to cut that in half. I'm going to divide it by 2. So this side is 0.42-ish. I'm going to put little approximates, okay? So I'm just trying to check and see if these things are equal. Now I'm going to do the natural log parentheses 7 divided by 6 parentheses. And that's giving me 0.15, you guys. So those aren't equal, okay? And that's because this whole thing is a number right here. Once I get that number, then I can half it. I can't apply the half to the inside and then log it. It'll get me something different. Yeah, that's a great question. Thanks for asking, because I'm sure some people were like, so can I make that cleaner? Okay. Okay. Isolate the exponential. Well, there's 2 exponentials, so you just have to isolate one of them. Okay, well, I think they'll always be like this, to be quite honest. Isolate the exponential. This doesn't really apply here. Number 2, log both sides. So I'm going to take the natural log of 2 to the 3x minus 2, and then the natural log of 3 to the 2x plus 1. Okay. Step 3, use the power property. So we're going to go ahead and take those powers and move them down. Now, if I don't use parentheses, I always get some students who do this. If you write it like that, the only 2 things that multiply are those 2 things, right? So I have to make sure that I understand that this entire thing is going to multiply by that natural log of 2. So I got to put some parentheses. Okay. Now keep in mind, this is just a number. Don't let it freak you out. These are just numbers. If I had 3x minus 2 and I had a 4 hanging out right there, what would you guys do? You bet. We distribute, huh? We just distribute that guy. So natural log of 2, that's just a number, like 0.69-ish, right? So I'm just going to take that natural log of 2 and I'm going to distribute it for both of these guys. Same thing with the natural log of 3, which is also a number. So we're going to get 3x natural log of 2 minus 2 natural log of 2 when we distribute on the left. And here we're going to get 2x natural log of 3 plus natural log of 3. Let me see where I'm at here as far as attendance. Okay, great. Okay. All right. So let's see here. There's a couple x's, right? There's an x here and an x here. So we want to make sure that for the solve part, we get all the x's on one side and all the non-x's on the other side. So what I'm going to do is I'm going to move this guy. Actually, I'll just do it without, I'll draw some arrows because I don't want to clutter it up. Okay. I'm going to move this guy over to this side of the equation. When I do that, his sign's going to change. So it'll be 3x natural log of 2, a minus 2x. natural log of 3. Now the things that don't have x's go on the same side also. So I'm going to take this thing and I'm going to move it over here to join the natural log of 3, which means his sign has to change. So the natural log of 3 that's on the right is going to have a 2 natural log of 2 added to it. I changed its sign. So we did a bunch of switching there. Does everybody feel okay about the switching? Okay. Now, why did we get them on the same side, the x's? Because if both of these have an x in it, then I can factor it out. Okay. And we're on the home stretch, guys. If I want to isolate the x, then I just need to divide both sides by, I was wondering, Ashlyn, I was all, Okay. Okay, it's an ugly thing to divide by, huh? You guys are like, oh my gosh, but that's not hard to do, it's just ugly. So that's our answer. Okay, now that'd be perfectly fine. If you're trying to plug this into Connect and you're like, well, you know, what's the easiest way to plug them into Connect? Then what I would probably do, because it's just easier to type, is I would move all these numbers out front and put them into the exponents. And I'm going to do it in my head, you guys. So let's see here. Natural log of 3. If I move the 2 up to the exponent, it'll be 2 squared, so it'll be a 4. If I move the 3 up to the exponent, it'd be 2 cubed, so that'd be an 8. And if I move the 2 up to the exponent, it'd be 3 squared, so that'd be a 9. That's a little easier to plug in, a little cleaner looking. Okay. But I'm pretty sure Connect Math accepts either one, you guys. Yeah. Okay, any questions on that one, you guys? Okay. So it's giving you a little hint. Okay, I like that hint. I'm noticing that this kind of looks like a trinomial. Like it kind of looks like an x squared minus 8x plus 12 a little bit, right? Yeah. It kind of reminds me of that, like a trinomial. Okay. So I think I could get it to look like that. Let me just do a little bit of tinkering around. Let me put that guy over here so everybody understands the goal. That's a quadratic. Okay. So this is e to the x squared, this first term. Because remember we said when you have an exponent on an exponent, that you just multiply those two by each other and that would get you 2x. Okay, so that's the only thing I'm going to change. And I just had to make that one little change because I'm going to make a substitution here. And I don't know what letter they use, but any letter you feel like, you guys. So let's say we use m. Let m be e to the x. If I let m be e to the x, then this would rewrite as m squared. Then the second piece would rewrite as 8m. Because we said anywhere where we have an e to the x, we're going to replace it with an m. You guys feel okay so far with that? Okay. And now it looks great. It's like, oh, we've been doing this forever. Factors of 12 that add up to -8. Okay, -6 and -2. Yeah, that looks like that'll work. Okay. So it's going to be m minus 6 and m minus 2 equals 0. So we got m equals 6 and m equals 2. And we're so used to stopping there, right? Like if I was tired, I'd be like, cool, got it. But we got to remember we're solving for x, you guys, right? The original problem didn't have any m's in it. It only had x's in it. So at this point, we got to remember to put x back, right? Put x back. So what is m really? M is really e to the x, right? So I'm going to make sure that I go in and put them back at this point. Okay. So it's going to be e to the x equals 6 and e to the x equals 2. So that's just us putting m back, right? Okay. And now all the stuff we were doing on the last few problems comes into play. Isolate the exponential, done. Okay, let me write them down. Isolate the exponential. Natural log both sides. Okay, so let me do that. Oh, I fit them. Okay, actually, you know what? I don't have to. I forgot I can move stuff. Forget about that sometimes. There we go. Okay, so we log both sides. And we know natural log of e, they cancel each other out, right? So we don't even have to use the power property on this. It's just x equals natural log of 6. We got lucky on this one. They just cross off, huh? Okay, so we didn't really have to do use the power property. And then, solve. Okay. So these are going to be our two answers. Let me box these guys. Okay. Yeah, it's kind of like two problems in one, huh? It's like, okay, we did this first part in black, and then it's like, now we got this whole new set of problem with the blue, huh? Yeah. Okay. So that was all about solving exponentials. The reason why these were all solving exponentials is because look where the x's were on all of these problems. If you go back to the very beginning, you guys, x was in the exponent, right? X was in the exponent. So these are all exponentials. Okay. And x in the exponent. We're going to switch gears. Now we're going to solve, oh, go for it, Nat, sorry.
So is there a way to check that by plugging it back into the system to make sure it's right? I mean, how can the ln of 6 and the ln of 2 both give you the same answer?
Well, it's kind of like when you solve any, it's kind of like when you solve this, right? It's like, what? Both 6 and 2 get me 0? But yeah, both 6 and 2 do get you 0, right? Like if you
okay.
put a 6 in, 6 squared would be 36. 8 times 6 is 48. So 36 and 12 add up to 48, right? So that would be 48 minus 48, so that gets you 0.
So when we do the ln of 2 squared minus 8 ln 2 plus 12, that'll get us 0?
Mm-hmm.
Oh, okay, got it.
Yeah. Yep. Let's do it. Why not? Instead of just talking about it. So the original was e to the 2x minus 8 e to the x plus 12. And we said natural log of 6 will work. So if I plug in natural log of 6 right there, and right there, right? Well, I can't cancel like this. I get some calc students that'll be like, bam, bam. But they're not right next to each other. Do you guys see if the 2 is in the way? You have to be right next to each other. So I'm just going to move this 2 up to the exponent. If I do that, it'll say e to the natural log of 6 squared. And now I can do it. I can cross these off, which gets me 36, 6 squared. I can cross these off, which gets me 8 times 6. And there we go. We're in that same position we were a second ago, huh?
Ah, got it. Thank you.
You're welcome. It is still kind of trippy, though, that two answers could totally get you 0. That kind of messes with the brain a little bit. Let's try the one for natural log. Was it 2? Yeah, 1, 2. Okay. So let's try that one. So if I plug in natural log of 2, e to the 2 natural log of 2, e to the natural log of 2. Okay, let's power property and put this 2 up in the exponent. So that's e to the natural log of 2 squared. And we'll go ahead and cross off this e to the natural log. So 2 squared is 4. We'll cancel out these e in natural log, so it's times 2. Let's see if that one works too. 4 minus 16 plus 12. Let's see, 4 and 12 make 16. Yeah, cool. That was awesome. Okay. All right. So we're going to move into solving logarithmic equations. So it's kind of cool. We know they undo each other, logs and exponentials. So when you're solving an exponential, you use a logarithm. When you're solving a logarithm, you use an exponential, okay? So it's gonna have kind of the same steps a little bit, same idea, okay? So this should feel familiar right here, the equivalence property. If you have the log base b of x equaling the log base b of y, so the bases have to be the same, you guys. If you have that, then x equals y. So what does this look like? This looks like if I have log base 3 of 7x equals log base 3 of 2x plus 1. Okay, then 7x has to equal 2x plus 1 in order for these the left side to equal the right side. Okay, so that feels familiar. We just kind of did that, but with exponentials. So let's try it. So first thing I want to check is, okay, do my bases match? And they do. So since the bases match, we can just set the argument, the stuff inside the logarithm, equal to each other and solve that. Now, I don't want you to think we're like dividing by log. We're not. That doesn't even make sense. Log is a word, right? It's not like I'm multiplying by the word log. Like I'm taking the log of something. So that's like saying you can divide by a square root sign. You know what I mean? Like that'd be weirdness if you had like x plus 1 and 2x minus 7. We can agree that in order for these two to equal each other, the insides have to equal each other, right? Okay, I'm not dividing by a square root sign, and that's why the square root goes away, right? But we're just saying that the insides have to equal each other, so when the square root acts on them, I get the same value out. Well, the same is true here. I'm not dividing by log, but I'm saying if these two logs are going to equal each other, then the stuff that the logarithm is going to act on has to equal each other. Okay, so hopefully that made some sort of sense. Okay. And from here, you guys are great. Move the smallest variable. 3x minus 1 equals 17. Add the 1 over. 3x equals 18. Divide by 3. X equals 6. Okay. All right, now, with log equations, you guys, you do have to check. Okay, so let me write that out. Logarithmic equations require checking them. Okay, logarithmic equations require checking the solutions. And here's the reason why. Do you guys remember, I think it was either last class or the class before, but I made you guys try to log 0. and I made you guys try to log some negative number, and your calculator said like error, domain error, math error, something like that. And we said, that's because we can't log a negative. We can't log negatives or zero, right? We can't log negatives or zero, okay? So sometimes what will happen is this number that you get down here, your solution, what will happen is when you plug them back in up here, sometimes it ends up getting you a zero or a negative. And then you're like, okay, well then I can't take that solution. Like let's say for example, you got the answer of x equals 1. Well, I noticed that when oh not 1, that's not gonna work. Let's do -1. So if I got the answer of -1, and I put a -1 into this first part, 5 times -1 is -5. -5 take away 1. That would be us logging a -6, you guys. And we already know that our calculator is just going to say error on that, right? So you want to make sure that the solutions that you get do not cause zero or negatives inside the logarithm. Okay? So let me type it out because it's going to be the first time we talked about it. Oops. I always try to catch the corner, but there, I got it finally. Okay. So, get out of the way. There we go. Make sure that the solutions you get do not cause the argument of the logarithm to be 0 or negative. Okay. So since it's, well, you'll do this in your head quite often, you guys, but since this is our first time doing it, I am going to write it out. So this is me checking. So I'm going to plug 6 back into both of the, I'm going to plug them in here, and I'm going to plug them in here. So 5 times 6 minus 1 is going to be 30 minus 1. So that's okay. It's not 0 or negative. Okay. Let me check the other one. 2 times 6 plus 17. Yeah, 12 plus 17 is not going to be 0 or negative. Okay? So we just want to make sure that we don't get 0 or negative. Not 0 or negative. Okay? All right. Here we go. We can use the equivalence property again because these both have the same base. What's the base on these? Very good. Yep. Okay, so since the bases match, we can go ahead and set the arguments equal to each other. And let's go ahead and solve this. So I'd add this x over. X plus x is 2x. Let's see, add the 7. And divide by the 2. Very good. And now let's just do a quick check. And like I said, a lot of you will probably just be doing this in your head. But I'm going to plug 6 back in right here and right here, right? And I can already see a problem. 6 minus 7 equals -1. Not a solution. I'm not allowed to log -1, right? So I'm going to cross them off. So our answer in this case is actually no solution, you guys. Okay? No solution. Any questions on that? Yeah. Sometimes you'll have 2. So let's say that you had 6, but then for some reason you had 8, and 8 worked, it's not going to work in this one, but let's say 8 did work, then it wouldn't be no solution, you would just keep the 8. Yeah, but if you end up with none working, that's when you put no solution, yeah. All right, not a solution since it's negative. It's our notes, so let me be clear why it isn't. Okay. All right, so this one is not, well, it requires a little bit of work before I can use the equivalence property. Because remember, the equivalence property says that if I have log base b of x equaling log base b of y, then x equals y. Well, I don't really have that yet, but I think we could do something to make that happen. So all that last section that you guys worked on will help. I know that subtraction of 2 logs, I can combine that into 1 log, right? So that'll become division, right? Yeah. So I'm going to go ahead and put 3x minus 4, oops, I always do that, over x plus 1. And now I have taken the 2 logs and made them 1 log. Now this fits the bill for the equivalence property, right? Both bases are 10 on this, and it does look like this setup. So I'm going to go ahead and say that the 3x minus 4 over x plus 1 has to equal the 2. Basically take the logs out, right? Okay. All right. And so let's go ahead and solve this. So what would we do to solve this? Yeah, multiply by the bottom. Okay. Variables on both sides, move the smaller. So we get x minus 4. And add the 4 over. Okay. We still have something to do though, right? We still have to check. So if I were to substitute 6 in to any one of these, right? Okay. So let's see. 3 times 6 minus 4 is 18 minus 4. Okay, that's positive. Cool. And let's try just the x plus 1. So 6 plus 1, yeah, that's 7. So that's positive. We don't want 0 or a negative. So he's a keeper. Okay. Okay. So if you have multiple logs, well, you know, you can condense them using those properties from the last section. And maybe you might be able to get them down to 1 log. I think this looks like that same situation, huh? Okay. So this time, though, we have the addition of 2 logs, huh? Okay. So addition really means what? Yep. So I'm going to take the x plus 3, and I'm going to multiply it by the x. Okay. And these have the same base. They both have base e's, their bases match. So we're going to use the equivalence property to say that x plus 3 times x has to equal 10. We're basically going to take the logs away. Okay, let's solve this. So x squared plus 3x.
Question.
Yeah.
Couldn't we just say x equals 10 and x plus 3 equals 10?
No, because these two things are multiplying by each other, these two, and they equal 10. So I don't know. It could be like 2 times 5 that gets me 10. It could be 1 times 10 that gets me 10. So like
So it has to
maybe,
be two different x's.
yeah, yeah. So I don't know. Maybe this one's the one that equals 5, and this one's the one that equals 2. I think that will work actually. But we don't typically set them equal to anything unless there's a 0 over here. Because in that case, these two things are multiplying by each other. Well, if two things are multiplying by each other to get you 0, either one of them is 0 or the other one is 0.
Oh, okay, that's what I was thinking of. Has to be 0.
Yeah. The second I put a 10 over here, gosh, I mean, maybe one of them's 5 and one's a 2. Maybe one's a 10 and one's a 1, you know? It gets a little tough. Yeah. Okay. So what do you guys think though? I mean, where do we go from here to solve this one? Yeah. Yep. So we're going to move it over so we have a 0. So move the 10 over, make it negative. And you guys said factor. Perfect. So we need factors of -10 that add up to 3. Perfect, guys. 5 and -2. So we're going to get -5 and +2. Okay. So now we just need to check these. So let's do checking -5. And then we'll do checking +2. Okay. So I'm going to plug -5 into x plus 3 right here. So when I do that, that gets me -2. I'm already done, right? He's out. Can't have negatives. Can't natural log a negative. Okay. So let's cross off -5. Now let's try 2. And don't forget, you got to plug them into both of them, you guys. So 2 plus 3 equals 5. That one checks. And of course, if I plug a 2 in right there, that one checks too. Okay. All right, you guys. How do we feel on that one? So only x equals 2 is the answer. The -5 was out. Okay. All right, so these are all log base 3s. Let's see what we can do to use the equivalence property. Okay. Any ideas on what we can do here, you guys? Because we want it to look like this, right? If log base 3 of something equals log base 3 of something else, then the two arguments equal each other. So can we get it down to a single log on the left-hand side? What would you guys do to make it? It is a single log, but yeah, move the 2 up. Okay, so let's put the 2 up in the exponent using the power property. So it's going to be log base 3 of x squared. Great. How about on the right-hand side? Can we make it a single log? Very good. Multiply. Okay. So we're going to take that 2 and we're going to multiply it by the 3x minus 4. Okay. So I'm going to just go ahead and distribute really quickly. 6x minus 8. Okay. So we're allowed to use this property now You guys did a great job of getting it to look like the left side. So let's go ahead and set the insides, the arguments, equal to each other. All right, so let's move the 6x and the 8 over. So change their signs. There's our 0. What do you guys think? Factors of 8 that add up to -6? Nice. Nice. Okay. So it's going to be x minus 2 and x minus 4. So x equals 2, x equals 4, maybe. You got to check these, right? Okay. So it looks like they're both positive. So clearly if I plug them into this first one right here, I'm going to be okay. So it boils down to me just checking the second one, you guys. This 3x minus 4 business. So I'm going to go ahead and plug it into 3x minus 4. So this is going to be me checking x equals 2. So if I have 3x minus 4 and I plug a 2 in, that's going to get me 6 minus 4. That's positive. Okay. Now let's check x equals 4. So 3 times 4 minus 4, that's going to get me 12 minus 4. That gets me 8, and that's positive. So that looks like that's going to work. Okay. All right. So we're going to keep them both. All right, you guys. Any questions on that one? Okay. So there are going to be times when we can't use the equivalence relation. For example, what if one side's a log and the other side's not a log? For that equivalence relation, both sides have to have a log on it, right? Okay. So when we do this, we're going to be logging both sides. So let me see if they have steps. They don't. So I'm going to write some steps out for us. Okay. So we're going to isolate the logs, I guess. Isolate logs. Condense multiple logs into a single log. Okay. Rewrite as an exponential. Okay, or yeah, I'll just write it like that. And then solve. But now we have another step, you guys, which is check. We didn't have check on the last one, right? Okay. All right. Let me put on one side here. Okay. All right. So step one, isolate all the logs on one side. Isolate logs on one side. Well, that's already done. I have the logs on one side and the non-logs on the other. Step two is to condense, right? Using the properties, write multiple logs as a single logarithm. Well, it's already condensed. So step three is to rewrite as an exponential. Okay. So I'm going to use the hook method. So that's hook, right? Hook method. My writing's really bad, you guys. Yeah. Okay. So we're going to start with the 5, and we're going to say 5 to the second power equals 3x plus 1. And that, from here, smooth sailing, huh? We're all like, okay, I can solve that now. 5 squared, got it. Maybe. We do have to make sure that he doesn't make the argument negative, huh? So if I plug an 8 in, 3 times 8 plus 1, so I'm plugging him in right here. Yeah, that's going to be positive. That's 25, right? Okay, so that'll work out. Great. All right. Let me write out the rest of the steps though, right? Rewrite as an exponential, solve. Step 5, don't forget, check. Okay. All right, step 1, get all the logs on one side, right? Isolate the logs on one side. Well, it looks good. I got logs on one side and non-logs on the other side. Done. But now we finally get to do step 2, right? Condense. And we condense by using those properties, you guys. So the properties you did last section, using the properties. Okay, so I'm gonna make those 2 logarithms become 1 logarithm. Oh my. Okay. So we got division I'm seeing, very good. So subtraction right there tells me that this is gonna become division. So it's gonna be x plus 6 on top of x minus 2. So condense, done. Step 3, rewrite as an exponential. In other words, the hook. So use the hook. So we're going to go ahead and say that 3 to the second equals that stuff. Okay, 3 squared gets us a 9. Multiply by the bottom. Very good. So those cancel out. 9x minus 18. Variables on both sides. Let's move the smaller of the two. We'll add 18. 18 plus 6, I think, is 24. Okay, cool. And we get x equals 3, possibly, maybe. Okay. Possibly, maybe. We still have to do step 5. All right, so let's see what happens if we were to plug 3 in. I'm taking 3, right? And I'm going back here and here to make sure I don't get 0 or a negative. So 3 plus 6 equals 9, that's positive. And 3 minus 2 equals 1, that's positive. We're good. We're going to keep them. Okay. All right, step 1. Isolate all the logs on one side, right? We actually have to do that this time, huh? So I probably would just move this one over. Yeah, add log x, very good. That seems like the easiest move. So I'm gonna add him to the other side. So we got the logs on one side and the non-logs on the other side. Okay. Step 2, condense using the properties, right? Condense. Get it into a single log. So let's see here. We got addition. So addition, we know, is going to become Yep, multiplication. So we're going to have to take x plus 15 and multiply it by that x. So let's see what we get here. X squared plus 15x. Okay. Step 3, rewrite as an exponential using the hook. Our base isn't there, but we all know that, oops, our base is going to be 10 on this one. So it's going to be 10 to the second equals all of that stuff. 10 to the second equals all that. Nice. Okay, so 100 equals x squared plus 15x. Let's move the 100 over to the other side, making him negative. This one doesn't come to me right away, guys. Negative 100, that adds up to 15. Maybe 20 times negative 5. Does that work? I think so. There's 20 times 5 is 100. Yeah, okay. And then if you add them, you get that. All right. So that's going to be x plus 20 and x minus 5. So x equals negative 20 and 5. All right. So we did the solve part. Now we're on the check part. So let's see what we get. Okay. So let's check x equals negative 20. We're done. We can tell already, huh? We plug negative 20. Yeah, you could do the quadratic also, yeah. If you like that better, if it was taking you a bit to get those factors, by all means, right? Can we already see this isn't gonna work, you guys? Okay, so he's out. All right, okay. He doesn't work in either one, by the way. We could have plugged him in here too and also have gotten a negative out. All right, let's try plugging 5 in. So this is us checking x equals 5. So 5 plus 15 equals a positive. And of course, if I just plug 5 in right here, that'll be a positive. So it looks like 5's a keeper, but negative 20 is out. Okay. It's kind of cool because it's putting together so many things that you guys have learned. It's like you're solving quadratics inside of a problem where you're also using your log properties. And I don't know, it's just a really good kind of review and a good way to show you how much you've learned. Because you guys are solving these factoring problems really quick. So I see the growth. I hope you guys see it too. You're like, yeah, I'm doing pretty good on these factoring. All right. One more, and then we'll take our break. Okay. So we want to get all the logs on one side, right? So isolate the logs on one side. Okay. Okay. So it looks like there's a lot of things you can do just because, well, I don't know. What are you guys thinking? Add the 3? Okay. So if we move the 3 over to this side, right, you would become positive. Then we'd also have to move this log over to this side though, huh? So then he would be negative. Okay. Well, that wouldn't be the only thing we could have done. We could have also just left the -3 and just moved this guy over to the other side, making him negative. It doesn't matter, you're gonna get the same answer either way. But it is kind of nice to have the variables on the left, huh? Okay, so it becomes division, you bet, good call. Okay, so it's gonna be, so oops, step 2, condense using the properties. All right, so it's going to be log base 4, the top, the first number is on top, and the second number on bottom. Step 3, rewrite as an exponential using the hook. So we're going to go ahead and say 4 to the third equals all that junk. Okay. 4 to the third. What is that? 64? Okay. And let's see here, that x squared plus 9, he's looking pretty good, huh? I'm thinking instead of multiplying by x plus 3 to both sides, what if we factor that x squared minus 9? And then that can just make the x plus 3 cancel. That's pretty nice, huh? Let's see, x plus 3, x minus 3. Yeah, and the x plus 3's cancel. So that's going to get us 64 equals x minus 3. Cool. That became easy fast, huh? 67 equals your x. That's a 7, you guys. Sorry, it's hideous. So now we're at the stage where we just need to check it. Okay. So we want to know if we plug 67 back in, right, to the x squared minus 9. Can you guys just tell they're going to be positives? Plug a 67 in, huh? So 67 squared minus 9. I'm not even going to get it. I'm just like going to go, yep, that's positive. I don't want to have to get it. And then 67 plus 3. Yep, that's 70. So that's positive, right? Okay. All right, so he's a keeper. So we got a word problem. Looks like we're using PERT, huh? Maybe I can leave this up. If $2,000 is invested, earning 2.5% interest, compounded continuously, determine how long it will take the money to grow to 45,000. Okay, they gave us the formula, cool. So we just have to figure out, you know, what to plug in where. Okay, so let's see, make a list of what we know. If 20,000 is invested, okay, so what would the 20,000 be? Which letter? Close. Super close. Yeah. So remember, P stands for the principal, which is the initial amount invested or earned. Okay, so we just got to remind ourselves, P is principal, and that's the initial amount invested or borrowed. Initial amount invested or borrowed. Okay. In an account earning 2.5% interest. So what would R be, you guys? And how would I have to write it though? Yeah, I got to move that decimal point. Boom, boom, 2 times. So it'd actually be 0.025 when I plug it in. Determine how long. Well, then that means T is question mark, right? Determine how long. it will take the money to grow to. So A is 45,000. Yeah, so remember A stands for the amount in the account after T years. P and A are so easy to mix up, you guys. You gotta really read. So always think of the principal as the initial, and the A is the amount in the end, right? The amount in the account after T years. Okay. All right, so we gotta plug stuff in. So let's go ahead and do that. So it's a little different twist than the last time, huh? Because we have the left-hand side. So that's new. Okay. But it makes it, how come every time I erase that, it comes back? Weird. I don't know what's up with that. Okay. But it makes it something that, you know, is this section. Because I'm about to solve an exponential, right? I'm solving an exponential. And that's exactly what we've been doing in this section. So number one, isolate the exponential. Okay. So we got to get rid of that 20,000. You're super close. Super close. Yeah. So we're going to divide the 20,000 since it's multiplying. Okay. So we got e to the 0.025t equals, and I'm just going to cross off 3 zeros for 3 zeros. So that is 45 over 20. Well, that can go further, huh? I think 5 goes into each one. Or 2.25. Okay, that'll work. 2.25. Okay. 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 Isolate the exponential. We did that. Okay. Now we're going to take the natural log of both sides. Natural log both sides. So we're going to natural log the left side. And we're going to, I think I can just put them right here. Natural log that. That is so strange. It does that. Okay. All right. And so we have natural log and e. They can cancel each other out, huh? All right. So we got natural log of 2.25 equals 0.025 e. Okay. So natural log both sides. And usually it's used the power property, but we didn't need to in this case, but usually it's used power property, right? And then step 4, solve. So we're at the solve stage. So we're almost there. Divide this guy out, done. We definitely need a calculator because I want to know how many years it's going to take to make my 20 grand become 45,000. So let's see, natural log of 2.25 equals, and I have to divide that by 0.025. Let me see if that's what everybody else is getting. Okay, I got a match. Yep. Okay, now it said, I read the directions. It says round to the nearest year. So we would say that it's going to take 32 years. Oh, that's way too long. Not for you guys. Too long for me though. I'll be too old to enjoy that. All right. Okay. Any questions on this one, you guys? It's a great way to show, you know, how we can apply what we learned earlier in the class session. All right. Pop quiz. They told us to use the model A equals QE to the RT, but what word in the directions actually let you know that you needed to use that formula? Close, good guess, yeah. So continuously. That is the one that tells me I'm gonna use the PERT one. Okay. We actually have two compound interest formulas, so it's like, how do I know when to use which one? The continuously is the one for the E. Okay. The following formula relates the energy in joules released by an earthquake of magnitude M, where M is greater than 5. Yeah. What is the energy released by a magnitude 6 and a magnitude 7 earthquake? Okay. So, looks like we're going to be plugging 6 and 7 in for the big M. Let's see what happens when we plug those in for the big M. So let's label this, huh? Okay. This is going to be for magnitude 6. Okay. All right. So we got log of E, and we just got to do the math there. Okay, calculator time. 6 times 1.44, 8.64. And I've got to add to that 5, oh, I already typed wrong. 5.24. So 13.88. Is that what you guys were getting? Cool. Okay. So we're solving the logarithmic equation now, right? Different steps. Step 1, isolate all the logs on one side. Done. Step 2, condense using the properties. Condense into a single log using the properties. Done. Step 3, rewrite as an exponential using the hook. That's where we're at. So we know that our base is 10. So when we use the hook method for this, it's going to be 10 to the 13.88 equals E. 10 to the 13.88 equals E. Now, I have no idea what this means to have this many joules. You know, like what the heck does that mean? So let me type it into my calculator. This is 7.586 times 10 to the 13th joules. Now they kind of give you a little comparison up here. It says 1 megaton nuclear weapon would have an energy release of 4.18 times 10 to the 15th. And the eruption of the volcano in Krakatoa in 1883 was 2.09 times 10 to the 19th. Holy cow. Okay, so we're definitely less than both of those on this. Okay. All right. Let me box that guy. Does it tell us how to write our answer anywhere? It doesn't really, huh? Usually for scientific, well, it looks like they're doing 2. So if I wanted to kind of copy them, which it didn't say we had to, but let's just for the heck of it. This 6 would round that 8 up, so it'd be 7.59 if I wanted to copy how they were writing their answers up here. Okay. Okay. All right. I'm probably not going to do 7 just because it would just be the same thing, you guys, right? We would just plug 7 in instead of 6. And so I'm sure that you guys could copy that.